So last day we have started and we have discussed about number systems basically and the theoretical part. And today I'm thinking of discussing uh, about number representation. Thinking of discussing about number representation, and actually under that we have to first discuss representing integers, representing integer numbers. So previously, let me remind things that we have discussed already. And we discussed about four number systems, decimal number systems, binary number system, octal and hexadecimal number systems, and conversion between those number systems, how to convert decimal to binary, decimal to octal, octal to binary, binary to decimal. Likewise, we have learned about number conversion. Okay, next, actually today, so after that we have to discuss about, all right, integer representation. This part, integer representation means representing whole numbers. Okay, integer representation. Please write down the heading, representation integers. Please write down the heading, representing integers or representation of integers. Right. Under that, okay, represented integers. Under that, actually, so what I'm going to discuss under that is basically there are three techniques. So let me write. There are three basic methods to represent integer numbers. So method number one, that is called sign and magnitude. Sign and magnitude. The first method is sign and magnitude. Method number one, sign and magnitude. Please write that as well. The first method is sign and magnitude. So basically, when there are integers nata purna sankhyaවක් තිබ්බම, so there are two kind of integers. So one is positive integers. You have positive integers. Positive integers. Right? Positive integers are represented using sign bit 0. Sign bit 0, and negative integers are represented using sign bit 1. So that is how basically this sign and magnitude represent a number. Positive integers are represented using sign bit 0, and negative integers are represented using sign bit 1. Positive sign bit 0 and negative sign bit 1. So Sydney, still you have the connection issue or now it's sorted?
Now okay, sir.
Okay, right, okay. Positive integers are represented using sign bit 0. Negative integers represented using sign bit 1. Okay, let's see. And the magnitude. What magnitude does? Magnitude represents the value in binary. So please write down this. So in sign and magnitude method, positive integers are represented using sign bit 0. Negative integers are represented using sign bit 1. The sign bit means basically it is called leftmost digit. Leftmost digit. It is in left side. This is also the sign bit is leftmost digit. I'll give you example, then it's easy to. Okay, for an example, let's say positive plus 10. Plus 10 is represented using sign bit 0. Sign bit, I'm going to highlight sign bit in red color or any some other color. Then 10 means using, let's say, using register size 8. Register size is 8 means you have 8 positions. So register size 8 means you have 8 positions. The first position is sign bit. The next 8 positions, next 7 positions, 0, 0, 0, 1, 0, 1, 0. The 1, 0, 1, 0, you know, 10 in binary is 1010. 10 in binary is 1010. And then, so this negative minus 10. Minus 10 using register size. Minus 10 using register size. Using register size 8 is 1 0 0 0 1 0 1 0. So here this is positive, it says positive plus. So this is negative, it says negative. Because you know that it is not possible to send the signs in wires. දැන් අපිට දීප ප්‍රශ්නයක් නේ මේක. wires වල signal යවන විදියනේ. එතකොට අපි දැනගත්තා the solution was sending high voltage and low voltage, which is represented using one will be high voltage, 0 will be low voltage. So we have a mechanism. High voltage represent 1, low voltage represent 0. But the problem comes when there are negative and positive signs. How to send plus sign? How to send minus sign? So the solution was, this is one solution. When it is plus, put the first bit 0. Indicate it's a plus number, positive number. First bit 1 indicate it's a negative number. Okay, so please write down this and represent these. Represent 34 minus 127 plus 127 and 0 using S and M, sign and magnitude. So please do this. So first write the node, then please convert these numbers to sign and magnitude. So if you cannot understand anything, please ask. I can explain again. First write down this, then represent 34 minus 127 and plus 127, 0 using sign and magnitude. Please represent. Okay, let's represent 34. 34 divided by 2 is 17, remainder 0, and 17 divided by 2 is 8, remainder 1. Then 8 divided by 8 divided by 2 is equal to 4, remainder 0. Then 4 divided by 2 is equal to 2, remainder 0, and 2 divided by 2 is equal to 1, remainder 0. So you take the value from bottom to top, and bottom to top, if you take the value, it's 1 0 0 0 1 0. So this is the value 1 0 0 0 1 0 is the value. But you need to represent this using 8 bits. Here you have how many bits? 1 2 3 4 5 6, and you need 2 more, 7 8. And the first bit is for the sign. So no need to color that. First bit is for sign. This is how you represent the number in sign and magnitude. So don't put 2 here, right? We are not going to put base 2 here, because in initial binary conversion we put base 2. But now this is actually integer representation. We don't need any other sign other than ones and zeros. That's the idea of integer representation. So this is the value. Those who were not there initially, what you can do is, so those who were not there initially, please write down this, and I'm asking you to convert these numbers in sign and magnitude. I'll give you 2 minutes. Please try to complete. Write down and please try to complete that. If you have any doubts, you can ask, right? I'm asking again from the previous. Okay, let's do this. It's okay, no worries. Let's do and understand this. So then plus 127 minus whatever 127. You divide by 2 and write the remainder. First you have to convert this to binary, no, anyway. Then it is 63 remaining 1. 63 divided by 2. It is 31. Remainder is 1. 31 divided by 2. It is 15 and remainder is 1. Then 15 divided by 2. That is 7 and remainder is 1. 7 divided by 2. That is equal to 3 remainder 1. And 3 divided by 2 is equal to 1 remainder 1. After you get this 1 remainder 1, so I'll write like this. After you get 1 remainder 1, you start from bottom to top and read. පල්ලෙහා ඉඳන් උඩට කියවන්නේ. පල්ලෙහා ඉඳන් උඩට කියවම it's 1 1 1 1 1 1 1. Isn't that so? Sit me. ඒක නේද එන්නේ? 1 1 1 1 1 1 1. You got wrong answer maybe. So is there calculation error or you predicted in wrong way? Sit me. මොකක්ද issue එක උනේ?
No, calculation error.
Calculation error, right? Okay. So please do always recheck, right? Always recheck these things after calculating. Otherwise, you'll get wrong answer. Today, actually, I have discussed with one of my friends doing A-level in Sinhala medium. So he's doing these classes in Balangoda area. I think sometimes you know Amila Padmasiri. So he's doing this in Balangoda area. So I discussed with him and I got to know. So even so, if most of the students, they, so especially the lessons like programming, they are trying to skip that, right? If they are trying to skip the programming part, then so one of the main reason is they are going to skip this. Give me a second, right? Okay, sorry. So most of the students, they are trying to ignore this part. The reason is they think that without that they can score. This is again one section that most of the students are trying to ignore these lessons and logic gate part and trying to answer theoretical lessons. But that is not really good. That is not really good because so you are purposely dropping some marks. So this one and this one, logic gates and programming, I feel that those are one of the easiest things to complete. Why? Because this you have maths. You can calculate and recalculate and find if there are error. If there is an error, you can recalculate. Recalculate means you can add. You know how to convert binary to decimal, no? Binary එකක් decimal කරන හැටි ඔයාලට මතකනේ. එකේ ගොඩවල්, දෙකේ ගොඩවල්, හතරේ ගොඩවල්. Likewise, you can add 1 plus 2 plus 3 plus 4 plus 8 plus 16 plus. So likewise, 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64. So you can add and see whether you get the same value. So similar to that, you are dividing and converting this decimal to binary. No? So, but after converting, you can just add and see whether you got right answer. So you have to add ගණකරාමි වගේ එකේ ගොඩවල්, ඒකට දෙකේ ඒවා, ඒකට හතරේ ඒවා, ඒකේ දෙගුණේ 8 ඒවා, ඒකේ දෙගුණේ 16 ඒවා, ඒකේ දෙගුණේ 32 ඒවා, ඒකේ දෙගුණේ 64 ඒවා. So likewise, you can add these numbers and see whether it generates 127. 64 plus 16 is 80. 32 plus 8 is 40. 40 plus 80, 120 altogether. Or otherwise, 64 plus 32, 96. And 96 plus 10 is 106 plus 112. 112 plus 8 is 120. 120 plus 4 is 124. 124 plus 2 is 126. And finally, 126 plus 1 is 127. Likewise, you can recheck your own answer. That's the beauty. So if you get wrong answer, it can be identified. So for an example, so one student got this kind of number. So what he or she can do is she can add these numbers. This is 1 plus 2, 1 plus 2 plus this is 64. 1 plus 2 is 3, 3 plus 4 is 67. Then you can identify that as wrong answer. So please do this both directions. So initially, if you are really confident about the answer, don't need to do this both directions, but otherwise do this both directions. So first convert decimal to binary and binary to decimal and check whether you get the same. Okay, minus 127 is this one. Minus means, you know, minus කියන එක පෙන්නන්නේ sign එක දාලා. Sign එකෙන් තමයි plus minus ගතිය පෙන්නන්නේ. Here sign is 0 because it is plus 34. Second one minus 127, it is this one. Then what is plus 127? What is plus 127? If this is minus 127, what is plus 127? Or the next one? Yes, Netuli. What is that? Minus 127 make a. What is plus 127? Plus how you represent? Plus sign එක පෙන්නන්නේ කොහොමද? Net me. Plus using
0.
plus using 0. Plus using 0, then 127 it's same. So this is how you represent plus 127. So I think it's easy. No? This is very easy. This is minus 127. This is equal to minus 127. And this is equal to plus 127. Okay, the next one is 0. 0, how you represent? What is this? So you need 8 bits because that is 8-bit register, right? Using size. Register size 8 means you need 8 bits. 0 will be 0, 0, 0, 0, 0, 0, 0, 0. What is this? What about this? What is first one? What is second one? First one is, yes, Tiasha. First one. Tiasha, can you hear me? Tiasha, are you there? Oh, no, not there. Okay, sit me. What is first one?
0.
0. The second one?
And also 0.
Yeah, that also 0. So the first one is positive 0 and second one is negative 0. But in mathematics, you don't have such things. But unfortunately, due to this representation, you get positive and negative zeros. Okay, that is a problem. So in this number system, so you can see positive and negative 0 are there. And it is, it has some error. It has subtraction error. For an example, okay. So in maths, what is 127 minus 127? What is the value? Plus 127 minus 127. What is the value? Yes, is it confusing or okay, Sachini, what's the value? 127 127 කඩු කරාම
0.
it's 0. So what is minus 127 plus 127? That is also 0. Same thing. So, but in this number system, you had another issue that plus 127 is this one, then minus 127 is this one. So you have to subtract. You have to subtract to get the answer. Then 1 minus 1, 1 minus 1, 1 minus 1. Likewise, you can just reduce. Then the ultimately it's 0 minus 1. So likewise, but this sign you are not going to actually reduce. 1 minus 1 is, so you can write in two levels maybe. Okay, like this. Then you can find the answer easily. So you can see the answer is 0, 0, 0, 0, 0, 0, 0, 0. So this is the answer. 1 minus 1 is 0, 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 and 0 minus 1, so it's minus 1, but you're not going to write, you're going to write as 0. So second one, you have to add both numbers. The first one is minus 127 and plus 1. Second one is 127 plus. You have to add those numbers. Can you add these numbers and tell me the answer? Here 1 plus 1 is 2. 2 means 1 0. Remainder is 1. 1 plus 1 is again 1 plus 1 is again 2, but previous one is also there, but you can't write like this. You can't add these numbers. Actually, what you have to do is the same. That means you have to write the positive number and then the negative number, and you have to subtract. Then you have to subtract. You have to subtract from positive number, you have to subtract the negative number. Then you will still get this answer, same 0. This is how calculations happens. Okay, then can you calculate this one using sign and magnitude? Let's, okay. Now you can see the one issues. Issue number 1, positive and negative 0 issue. Sign and magnitude issue number 1, positive and negative 0 issue. So please write down the answers as well as, okay, so let me, so this part that I think you have finished writing, no? The first part. Netoli, finished writing the first part?
Yes, sir.
Okay, then can you write the second one, the examples quickly? This is equal to plus 34, and this is minus 127. This is plus 127, and this is plus 0. This is negative minus 0. So quickly show this. Quickly show this in your book. මොනවා හරි තේරෙන්නේ නැති දෙයක් තියෙනවා නම් අහන්න. එතන අපි මේ ඉගෙන ගන්නේ number system representation. කොහොමද ධන සහ ඍණ සංඛ්‍යා නිරූපණය කරන්නේ? How to represent positive numbers and how to represent negative numbers. So one method number 1 is sign and magnitude. In this method, first bit is used for sign. If it is plus sign, positive number, we will start with 0. If it is negative number, we will start with 1. That is the mechanism. After that, you can write the value. This is called magnitude part, the value. This is magnitude. This is magnitude part. So one issue of this sign and magnitude is having positive and negative zeros. Okay, please highlight and write down that.